Hello, this is midterm review for research methods, and we're going to be going through all the sorts of things you're likely to see on the midterm, how to answer these questions. I'm going to start by talking about the things I'm not going to do in this review session in detail, and that's basically the stuff that we're going to see on the multiple choice. Some will be just like short little one-step questions, right? Calculate this probability given these other probabilities, right? You have to use a probability rule, maybe, right? Or like find, some small calculation, find the 24th percentile of this data or something, right? Just one little calculation. That could be a multiple choice question, but a lot of the multiple choice questions are on definitions, right? And so the definitions, these are the things that we want you to know and understand, but they're not going to come up on the long answer questions. And so I've got a little list here of things that really come up a lot. Measures of central tendency and measures of variability, measures of position, just understanding what they are, what they mean, how to interpret them, right? This is mean, median, and mode. This is range and standard deviation. And the measures of position are things like percentiles and quartiles, right? We are classifying data, all that stuff about discrete versus continuous, qualitative versus quantitative, the different levels of measure, ratio, ordinal, all that stuff, right? These are things that make very good multiple choice questions, and you can definitely expect to see some of that on your test. So if you don't remember any of these definitions, you could go back and look at those, right? Make sure you understand what does it mean for something to be ordinal data, for instance. Right? The different sampling methods. You would have talked about the sampling methods: simple random sampling, systematic sampling, cluster sampling, stratified sampling, convenience sampling. Right? If we give you a question that describes a scenario, you should be able to say, okay, well, which type of sampling did we just describe? And then types of graphs and charts, right? So just understanding what is a bar chart, pie chart, box plot, histogram, ogive, right? All the charts you talked about so far. Just what are they for? How do you describe them? Probability approaches, right? There could be a question on that. The classical, empirical, and subjective approaches. And then questions about independent and mutually exclusive events. How can you tell if events are independent or mutually exclusive? So these are all different things where, they're mostly just definitions. If you don't know them, you can go look them up. What we will be focusing on today is the long answer questions. How do we go through, get a question and solve it start to finish? All right. So let's just get right into that. The first question we're going to do is going to be a question about our summary statistics. Right. So we're going to have some data. We're going to have some numbers here. We're going to have some numbers like 4, 7, 9, 12, 15, 13, 15, 9, 3, 9, 7. Right, so just giving some numbers, and there might be a story behind the numbers, right? They might say, oh, this is the amount of time it takes a certain number of students to travel to work every day or something like that, right? They'll have some description of what these numbers are, but what they're going to ask you to do with these numbers is calculate a bunch of things, right? You're going to have to find the mean, the median, the mode, range, maybe the standard deviation, although it's kind of a lot of data for standard deviation. I think I'll do standard deviation example with less data. Usually with standard deviation, we don't make the data set too big, otherwise it takes a while. All right, I'll just, but these are all the sorts of things that we're going to be calculating with data like this. All right, and then maybe we'll do some percentiles and stuff as well. Although I'll do another example with percentiles, right? But you could combine these sorts of things, right? You have a bunch of data and there's a lot you can do with it. A lot of things you can calculate. Okay, so let's just start with these 4, and then, like I said, I'll do other examples for the standard deviation and other examples for the for the percentiles and stuff. So for the mean, what are we going to do? Well, we have to add them all up, right? So we're going to do the 4 plus the 7 plus the 9 plus the 12 plus the 15 plus the 13 plus the 15 again plus the 9 plus the 3 plus the 9 plus the 7. We have to add all that up and see what do we get. So we get our calculators, right? And we plug that in. Right, so 4 plus 7 plus 9 plus 12 plus 15, 13, 15 again, 9, 3, 9, and 7 gets me 103. And then what are we going to do with that? We're going to divide that by how many numbers we just added up. So how many numbers are there here? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 numbers on this list. So 103 divided by 11 is going to get me 9.364, right? Depending on how many decimal places you're rounding to. Right, and pay attention to the test and to the questions, right? The test might tell you how many decimal places to round to. So make sure you're rounding to the number of decimal places the test says you should, if it does say a specific number. Okay, so that's the mean. Now the median we get by adding up, no, not adding up, by putting all the numbers in order. We have to sort them, right? This is going to be true for the median and for percentiles, right? For the median and percentiles, we need to sort the data, because if you just look for the middle number here, right? Hey, what's in the middle? Oh, it's 13, right? Is 13 going to be the answer? I mean, maybe, but probably not, right? It could be that 13 still is in the middle after we line things up, but it may be that it's not. So we're gonna line things up. So there's a 3, then a 4, and then a 7, and then a 7, and then a 9, a 9, another 9, 12, 13, 15, and a 15. And I wonder if I got all of them, I should count to make sure. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11. Good, I got them all. All right, that's all 11. So now that they're in order, for the median, I'm going to want to find the one that's right in the middle, right? And so if I have an odd number like this, if I have an odd number of these, then there will be just a single number that's right in the middle. And so we can pick out this number here as being right in the middle, because there are 5 numbers to the left and 5 numbers to the right. Right? So 9 is the median. Okay. If we have an even number of data points, then we're gonna have to do something a little bit more work, just like one extra step. We're gonna have to find the middle 2 numbers, because there isn't gonna be a middle one, right? If you have an even number of data points, right, there's no one data point in the middle, right? There's 2 middle numbers. And so we would take those, add them together, divide by 2. Right, so a simple example of that, right? If I had 3, 7, 9, 12, 13, 13, right? There are 6 numbers in this list. It's an even number of numbers. So I would take these 2 and I would do 9 plus 12 over 2 to get their average, right? What's exactly halfway between 9 and 12? And we would get 10.5. Right? So that's how you would do it if you had an even number of data points. Right, what about the mode? Well, for the mode, we're just counting up how many times each number appears. And for that, it is easier to do after you put them in order. You don't have to put them in order for the mode, but since we're doing the median anyway, it's nice that we have those numbers in order, because now it's easy to see there are 2 7s and 2 15s, but there are 3 9s. So the mode is 9. All right, I should have said the median is 9, and the mode is also 9 in this case. right? Now it's possible for there to be a tie, right? If there had only been 2 9s, then there would have been 2 7s, 2 9s, and 2 15s, and those all would have been the mode. You would have said the mode is 7, 9, and 15. They would all have been modes if we had a tie. So you can have a tie for modes, and that's totally all right. And you should not be surprised at all if that happens. It's very normal. All right, now the range is easy. And again, it's easier if you put it from lowest to small from lowest to highest, because now we can see the lowest is 3, the highest is 15. So we're just gonna do 15 minus 3 is 12. That's the range. Right, these first three are measures of central tendency. So they're talking about where is the middle of the data, right? 9.364, 9, or 9. Range is a measure of spread. That's how spread out is the data. Right, and range is a simple way to do measures of spread, right? Because all you need to do is highest minus lowest. Now, along with this sort of question, sometimes we ask a follow-up that's about the shape of the distribution, right? Distributions have different shapes, and you're going to be asked about the shape of distribution somewhere. But it could be here, it could be in a question about like frequency tables, it could and histograms, it could be in a question about box plots. There's a lot of different places we can ask about the shape of a distribution. What you need to know for shape of a distribution, right, is there's a couple of different shapes that we're interested in. We're interested in these symmetrical ones. We're interested in ones where they're asymmetrical, right? So the tail could be longer on the right or on the left, right? And then there's also other weird, lumpy, irregular distribution shapes that aren't nicely symmetrical, and they're also not one of these ones with a long tail, right? But the ones with a long tail and the symmetrical one, these are the ones we're interested in here, right? So this is symmetrical. This is skewed to the right. We always say it's skewed in whatever direction has the longer tail. All right, so a long tail to the right is skewed right, and then a long tail to the left is skewed left. And what does this have to do with mean, median, and mode? Well, when the data is symmetrical, all of them should be around the same spot, right in the middle. But when it's skewed right, what you're going to get is you're going to get the mode is going to be up at the peak. The median is going to be a little bit to the right of that if it's skewed right. If it's skewed left, it's going to be a little bit to the left of that. And the mean is going to be further to the right, because all that data way up there in this tail is pulling the mean to the right, or in this case, to the left. Right? So based on this data, the fact that the mean is higher than the median would indicate to us that it might be a little bit skewed right. Right? The fact that the mean is greater than the median means it might be a little bit skewed right. We're not going to be able to be certain just from that information, right? Just from that one piece of information, that doesn't tell us by itself the shape of the distribution, but it's a hint. If you had to go just based on what you see here, that would be the conclusion you might draw. You would say it's a little bit skewed right, because the mean is a bit bigger than the median. It's not a lot bigger than the median, so it's not very skewed, right? We can get distributions that are more skewed or less skewed, more symmetrical or less symmetrical. Okay, so those are our mean, median, mode, range. The next example I'm going to do is about standard deviation. So let's do standard deviation. With standard deviation, again, you're going to have some data. And you're going to be asked to find or calculate the standard deviation of that data. And it's probably not going to be a ton of data, just because this one's kind of time consuming. This one involves a table, right? So you're going to have some data, and that's going to be what we call X, right? X is going to be our data, and we're going to have, say, 5, 7, 10, 13, and 15. That's our data. And so when we're calculating the standard deviation, the first step is going to be to calculate the mean, right? So what's the mean of this data? Well, we added up 5 plus 7 plus 10 plus 13 plus 15 is 50. So the mean is 50 divided by 5. We're dividing by 5 because there are 5 numbers on the list. You can count them. So the mean is 10, right? And if this is a sample mean, we're going to write X bar, right? If it was a population, we would write the Greek letter mu. Okay, but let's just say in this example that we have a sample. And it's going to make a difference whether we have a sample or a population. But in this case, let's just say we have a sample. So what we're going to be calculating is going to be S, the sample standard deviation. With a population, we have a different symbol. We have this Greek letter sigma. So it matters for the symbol we use. It also matters for the calculation. We're going to see in one of our later steps that whether we have sample or population is going to make a difference. But in this example, let's suppose the question tells us that this is a sample. So what we're going to do now is we're going to find the deviations. So the deviations are what we get when we take the data and we subtract the mean from it. Right? So 5 minus the mean, 5 minus 10 is negative 5. 7 minus 10 is negative 3. 10 minus 10 is 0. 13 minus 10 is 3, and 15 minus 10 is 5. So we get this. And when you're done, this column should add up to 0. It's not required that you add this column up, but it is a way to check your work. Right? If you've done it correctly so far, you will be getting a 0 here. If there's rounding involved, it might be like 0.01 or negative 0.02 or something like that, but it'll be really close to 0, right? That's just the rounding. Right, in this case, I didn't have to round anything because my mean was a nice whole number. So I just got exactly 0, which is what I want to see. Those are my deviations, right? So we had step 1, find the mean. Step 2, find the deviations. That's subtracting. Step 3 is going to be square deviations. Right? And so that's going to be, well, we take whatever we have and we square it. Right? So our X minus X bar, the deviation, we're going to square each of these. And so negative 5 squared is 25. Negative 3 squared is 9. 0 squared is 0. 3 squared is 9. 5 squared is 25. I want to point out that if you're on your calculator and you type in minus 5 and then hit the squared button, there is a good chance that your calculator will give you a negative 25. That's because your calculator can't tell the difference based on the way you typed it of did you mean negative 5 squared like that, or did you mean negative 5 squared like that? And your calculator is very likely to assume that you meant the first one when actually we meant the second one, right? And so you can fix that problem by using brackets, right? You can type brackets minus 5, close brackets, and then hit the squared button. And that would work. The other thing you could do is you could just ignore the negatives, right? Because the negatives really don't matter. Negative 5 squared is the same as 5 squared. Right? So we had some negatives here, but over here, we're just ignoring them. They don't matter at all. Right? Negative 5 squared is the same as 5 squared. Negative 3 squared is the same as 3 squared. Right? So the negatives just get dropped. Right? Everything here is positive. And now we add it up. All right, we add it up, and this is the sum of squared deviations. Sometimes this is labeled SSX, which you won't really need to know in this class. But if you go deeper in statistics, there are times when this SSX actually becomes useful on its own, but we don't need to know it. It's just for us, it's just a step along the way. Right, so 25 plus 9 plus 0 plus 9 plus 25 is 68. So we've got 68 here. Right, and now step 5 is we are going to find the variance. So the variance, what we're going to do is we're going to take the 68, right, the thing we just found, the sum of squares, sum of squared deviations, and we are going to divide by n minus 1 because it's a sample. If instead we'd had a population, then we would have done the population variance is that same number divided by the size of the population, right? So we would not subtract 1 if it was a population, but because it is a sample we're doing, we're going to subtract 1. So we're going to do 68 divided by 5 minus 1, which is 4. Right? That is our formula. So you can see we're doing a lot of different operations here, right? We're finding the mean, right? And then we're doing deviations, that means subtracting. And then we're squaring things, so we have an exponent here. And then we're adding those up, adding up those square deviations. So we got plus here. And now we are dividing by n minus 1. So 68 divided by 4, right? And that's going to get us 17. And that's called the variance. Again, this is not something we use a whole lot. You might have heard about the variance in this course, and you probably have heard about the variance in this course. But for us, it's mostly just a step along the way. Right? This is something that we can use as a measure of variability. We can compare the variances between multiple groups to see which one is more spread out. But the main thing we're doing now is we're just going to get step 6, which is going to be finding that standard deviation, which involves taking the square root. So we take the square root of the variance and we get our answer. That's our answer. Square root of 17, right? Which we can plug in our calculator to turn into a decimal. We get 4.123. And there we go. That's our final answer. So that's how you calculate the standard deviation, right? There's a lot of steps. And, your formula sheet that you're going to get is going to have a formula, but I'm going to warn you that formula is going to look like that, right? Now, if you've got some, math experience, then you might be able to read that formula and understand what it's saying and translate that formula into this method. But if you don't have that math experience, then you're not going to be able to look at that formula and say, oh, I know what to do, right? So if you're hoping to just be able to look at your formula sheet and know what to do, that might work for some questions, but that's probably not going to work for this question, right? For standard deviation calculations, you need to know this method, right? So, luckily it's a nice video. You can go, pause, rewind, make sure you know this method step by step. Everything we did. We found the mean. We did each data point minus the mean to get our deviations. Then we took those deviations and we squared them. Then we took our squared deviations and we added them up to get the sum of squares. Then we took that sum of squares and we divided by n minus 1 because it's a sample. If it was a population, we would have divided by n. But we divide by n minus 1, and that gets us 17, which is our variance. And then we take that variance and we square root it to get the standard deviation, which is our final answer. Okay, so that's it for the standard deviation part. I'm going to now do percentiles and box plots, and then we will probably have a break, and I'll continue with more stuff in the next video. I'm going to break this up into a little playlist. So for percentiles and box plots, again, you're going to have a bunch of data given to you, and it's going to be given to you out of order. And the first thing you're going to do is you're going to put it in order. Okay, so I'm going to type out some numbers here. I'm going to type them out already in order, but you should just be aware that when you get the data on your test, it's not going to be in order, right? Your first step, step 0, before you do anything that I'm going to do, is going to be to put it in order, right? So I'm gonna have the benefit of starting with things already in order. Okay, so I've got my data here. I've got, well, let's see, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 numbers here. It's important. You want to put it in order and you want to count how many you have. Right? So these are 14 numbers. Right? And of course, on your test, this will have some story. This will be like, oh, you are doing a survey of your company's customers. And in this survey of 14 customers, you're trying to find out about the ages of your customers, right? And so these are the ages you record. Right? You get some younger customers, you get some older customers, and you want to know about some percentiles. Right? So we're going to do a couple of things. We're going to calculate a percentile using the long method that you use for any percentile. And then we're going to make a box plot, which is going to be involving calculating median and quartiles and stuff, but we're going to be using the fast method for that. Okay, so let's do the regular, just get a percentile method, right? So what is the, let's say, 60th percentile? Okay, so the 60th percentile. We have a couple of formulas, right? So the first formula, well, we don't, the first formula is going to be about not the percentile, but the location of the percentile. And the formula looks like this. The location of the percentile is n plus 1 times the p over 100. So in our case, we're getting L60, the 60th percentile. The location of the 60th percentile is going to be 14 plus 1 times 60 over 10, over 100, I mean. Right, so 15 times 60 over 100 gets me 9. And if I get a whole number, I'm really happy, right? If I get a whole number, I'm really happy because this means that my step 2 is really easy. This tells me I'm just looking for the 9th number on the list and I'm done. Great. Just count. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's there. 40. P60 is 40. Done. What does that mean? Right? You need to know what these things mean as well, of course. Right? So the 60th percentile is 40 years old. That means that 60% of our customers are under 40. And the remaining 40% are over 40. Right? Assuming that this sample is a reliable representative sample and it does represent our customers well. Right? If this is a nice representative sample, then we can say, all right, we know 60% of our customers are less than 40 years old. Cool. All right, but what if we're not so lucky, right? We're not going to stop here. We're not going to do like only the easiest example. No, we've got to do something a little bit harder too. So we're going to do what is the, let's say the 37th percentile. Okay, so here we're going to do the same formula, right? We're going to do LP for L, in this case it's L37, is going to be 14 plus 1, so 15, times 37 over 100. Okay, so 15 times 0.37 gets me 5.55. So this is not a whole number. All right, so that means we have work to do. So the way we're going to find this actually the 37th percentile is, so we're going to take this number 5.55 and we're going to say, all right, that's between 5 and 6, right? We're going to say this is between 5 and 6. So that means our percentile should be somewhere between the 5th number, which is here, right? 1, 2, 3, 4, 5, and the 6th number, which is there. Right? If our L had turned out to be 5, the answer would have been 29. If our L had turned out to be 6, the answer would have been 32. Our L turned out to be somewhere in between 5 and 6. So our answer should be between 29 and 32. And so what we're going to do then is we're going to do the decimal times the difference plus the lower. Okay, so different profs explain this formula different ways. This is my favorite way to explain it. The decimal times the difference plus the lower. So what's the decimal? The decimal is just this part, right? The 0.55, right? We're kind of done with the 5. That 5 got us the fact that, oh, we're between 5 and 6. Okay. At this point now that we know we're between 29 and 32, we kind of don't really care about the 5 anymore. We care about what comes to the right, what's after the decimal. So the 0.55, that's my decimal. And now we're going to multiply that by the difference. What is the difference? What difference am I talking about? I'm talking about the difference between the two numbers we just highlighted. Right? The difference is going to be 32. 32 minus 29. We always do the larger minus the smaller here, right? We want a positive number here for the difference, right? So this is 3. So 0.55 times 3 plus the lower. What do I mean by the lower? I just mean the lower of the two numbers I got, the 29 plus the 32. I'm talking about the 29, right? So I'm going to do 0.55 times 3. All right. So that's going to be 1.65. And then plus 29 is going to get me 30.65. And that's going to be my final answer. Okay, so that's how we do percentiles when we have to do the full percentile method, which is usually. We're going to see in the box plots I'm going to do next that there are very specific cases where we can use shortcuts. But for most percentiles, this is the method we've got to use. Okay, so we've got that. And I'll select this. I want to copy these numbers over to the next page because I'm going to use the same numbers now when I do a box plot. Okay, and again, we want to interpret this. This means that 37%, right? 37th percentile, 37% of our customers are younger than this age, 30.65 years old. Okay, so now we're going to do a box plot. And so for the box plot, we're going to need the 5-number summary. The 5-number summary is the minimum, the first quartile, Q1, the median, which is also Q2, the third quartile, Q3, and the maximum. Okay, minimum and maximum are very easy, right? The minimum is 24 because we put these in order. Again, they have to be in order, right? If the numbers aren't in order, make sure the first thing you're doing is putting them in order, lowest to highest. If they're not in order, none of this percentile, quartile, box plot stuff works. It needs to be in order, right? So these are in order, so we're good. So the minimum is 24, and the maximum is 91. Easy. The median, we know how to calculate the median, right? We have 14 numbers here. That's an even number. That means that for the median, there's going to be 7 numbers on each side. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Perfect. The median is right here. We're going to do 35 plus 35 over 2. Yeah, you can probably figure that one out. That's 35. Right, so our median is 35. Okay. So far, so good. Pretty quick so far. Now, for the quartiles, there is a shortcut method. Right? Now, the shortcut method will not give you exactly the same answer as the full method. Right? So you have to be a little bit careful here, right? Like if it's a computer marking it, then the computer might not mark it correct or whatever. But the fact is that with percentiles, there are multiple formulas that all give very slightly different answers, and it's very common when dealing with percentiles to have this, 2 different people calculated it slightly differently, got slightly different answers. There is no one formula that is the formula for percentiles. Right? It's just one of those weird things. Like most of the time in math, we have like the formula that is the formula. Percentiles, we don't, right? Even if you go into like Excel, there's 2 different percentile equations that you can use, the inclusive and the exclusive and stuff. So, and neither of those are necessarily going to be exactly the same as what we're going to get when we do it by hand. And when I teach stuff at the textbooks Ryerson uses have a slightly different method than the one Humber's textbooks use. So it's all just kind of a mess, right? Everyone gets slightly different answers for percentiles based on the method. It doesn't make a big difference, right? Everyone's answers are going to be close, but not identical. So this Q1, right, is the 25th percentile. And we could use the full method that I just showed you to solve that. But I've already shown you that. If you want to do that, go ahead. But I'm going to show you the shortcut. The shortcut is we're going to take all this stuff that's to the left of the median, and we're going to find the median of that. What do we have to the left of the median? We have 7 numbers. That's an odd number of numbers. So the median should be right in the middle. There it is, 27. All right, so the Q1 is going to be the median of the first half of the data. And then our Q3, we're going to do the same on the right. All right, there are 7 numbers over here. The middle is this one, 49. Okay, so there we go. We've got our 5-number summary. We have our quartiles using the shortcut method. Right, now if you use the full method, you might get exactly the same, or you might get slightly different. It depends on your n, actually. It depends on the number of data points. For some numbers of data points, you'll get exactly the same thing. For some numbers of data points, you'll get very slightly different answers. Excuse me. All right, so this is our 5-number summary. Now, if we want to make just a basic box plot without checking for outliers, this is all we need. Now, I'm not sure exactly what's going to be on your midterm because I haven't seen your midterm for this term. For some courses and for some years, we have just basic box plots. For some terms, we have box plot plus checking for outliers, right? So if the question mentions checking for outliers, if it says outliers or fences or anything like that, then you got to do more work than I'm going to show you right now. I will show you how to do that. But before I do that, a more advanced part, I'm just going to do the basic box plot. The basic box plot looks like this. We've got our number line. Right, so what we're going to do is we're going to start by drawing a box. The box goes from Q1 to Q3. Right, so from 27 to 49. So 10, 20, 27 is going to be around here. And I'm going to label this so that the person marking it knows what I'm doing. Right, so that's the bottom of my box, and the top of my box is going to be up at 49. Okay, so it's going to be like right here. 49. I'm labeling all of these so that whoever's marking this knows what numbers I'm referring to here. That's my Q1. That's my Q3. The median is at 35. Okay, so 10, 20, 30, 35 is going to be around here. And I'm going to draw whiskers. Whiskers going down to 24. So 24 is down here. And up to 91. 91's all the way up here. That's a really long whisker. Okay, so there we go. That's my basic box plot. And if I want to know about the shape of the data, remember I said the shape of the data, they could ask you about the shape of the data in a few different places. This data is skewed to the right. And we can tell because the right half of the box is longer than the left half of the box, and the right tail is longer than the left tail. When you see that pattern, that tells you you've got a right skew. All right, we got the long right tail and the short left tail. This is skewed right, or positively skewed. Right? Oh, I should finish labeling. Right? You want to label all your points. Right, so there we go. Basic box plot. If you don't need to worry about outliers, then you're done. That's it. What if you do need to worry about outliers? If you do need to worry about outliers, then the box part is still good. It's just the whiskers that might be affected. So what we would have to do before drawing those whiskers is we would have to do a little bit of a check for outliers. So we would have to find what are called the right fence and the left fence. Sometimes these are called right inner fence and left inner fence. Anyway, the right fence is Q3 plus the IQR. And the left fence is Q1 minus the IQR. Okay, so what's the IQR? IQR is actually really easy. IQR is called the interquartile range, and that's just Q3 minus Q1. It's the length of the box. Right? How long is this box? Right? It's the range of the middle half of the data. That's what the IQR is. Right? So in our example, it's going to be 49 minus 27, which is 22. All right, so that's my interquartile range. And so I use this interquartile range to calculate my fences. My right fence is at 49 plus 22 is 71. And my left fence is, sorry, oh my goodness, I'm very sorry. I almost messed up pretty badly. That's not the formula. It's 1.5 IQRs for the fences. One and a half times the IQ, and that's for both fences. Just had a little slip of the brain there. Happens to everyone. So 49 plus 1.5 times 22. Right, which is 33. So 49 plus 33 is 82. And then here we have 27 minus 1.5 times 22. So 27 minus 33 is -6. So where are my fences? My fences end up being at -6, so like down here, and at 82, so like around here. Now the fence is not actually part of the box plot. The fences are used to tell us where we might find outliers. And so in this example, this 82 says that anything beyond 82 is suspected of being an outlier. So what's beyond 82? If we look back to our original data here, right, what's beyond 82? Just the 91. The 91 is the only thing that's past our fence. The 76 is close, but it's not past the fence. So we're not worried about the 76. The 91 is our only suspected outlier. So what we're going to do is we're still going to draw the box the same way with our new advanced box plot here. All right, we're still drawing the box in the same places. 27 to 49. Still drawing the median of 35. That part's all the same. But now, this 91, we're going to call it a suspect outlier, and we're going to put a little star here and label that 91. If the 76 was also an outlier, then we would have put another star, right? You get a star for every outlier, and there can be more than one. In this example, we just happen to have the 1 on the right. What about on the left? What about this fence? Well, anything below this fence gets the same treatment, right? So is there anything below -6? No. The smallest number is 24, right? So there are no outliers to the left. So if there are no outliers to the left, then the whisker just goes down to the minimum, and that's that. Goes down to 24, no problem. So the box plot mostly looks like it did before, but this right whisker can't go all the way up to 91 because 91 is suspected of being an outlier. Where does the whisker go to? Does it go to 82? No, it does not. All right, it does not go to the fence. It goes to the maximum non-outlier. It goes to the 76. So where's 76 on here? That's going to be around here. That's 76. That is where my whisker goes to. Now, I've seen some people have slightly different methods for this, but this is the method that I've seen the most. And this is the method I teach. So if your professor taught you something slightly different, then you can go with what your professor taught you. This is how I've always known it. All right, so after doing this calculation to find the fences, 82 and -6, we find out what are our outliers. There's no outliers on the left. And on the right, we have a single outlier at 91. Outliers get little stars to indicate them. And then the whisker goes to the highest non-outlier. If we had an outlier on the left, this whisker would have gone to the lowest non-outlier, right? It's just like outliers don't count, all right? Whiskers can't touch outliers. Whiskers go to the highest and the lowest numbers that are not outliers. Right, and so this is our more advanced box plot where we've indicated an outlier. And that's it. That's percentiles and box plots. So like I said, this is going to be a good place to stop this part of the recording. We can cover some more in the next bit.